Hello. Just 1 second. Just going to double check the stream. Okay. Hello. Welcome to another episode of Tedious Layout on a module I'm designing that's going to be open source. That you can just build. Maybe by the next episode I'll start uploading to GitHub. It looks like don't have Inkscape open. One moment please. Hello Inkscape. It's going to look possibly something a bit like this. It's designed around the RP2350 with a nice, the green square is a nice high resolution display. It's 240 by 280 and it's tiny. It's kind of like one of those watch displays, smartwatch displays, maybe not as dense as an Apple display. Just going to make sure my phone's on mute. And it's basically just like a general purpose programmable module, a bit like an Ornament and Crime or a Expert Leapers Disting, except for you can build it completely yourself. Completely open source design, and there's no soldering required, because the idea is that the whole thing is going to get built at PCB, a thing called PCB-A, which is pre-assembled PCBs, where it goes through a pooling system where you only need to order 5, minimum 5, and they will use machines to pop all these components on for you, and then probably hand assemble some of these bigger connectors for you. And it's quite affordable. Whoops, I probably shouldn't be saying that. It's quite affordable. Yeah. But I've added all the bells and whistles, and it's quite complicated. It's taken about probably since how long has it taken? It's taken 1, 2, 3, 4 1.5 hour sessions. Probably it's going to be 5. So what was that? Wait, 6 hours? Yeah, sorry, 6 hours I've probably spent on it so far, and it's still not complete. If you look, it's just a complete mess. The problem is I'm using this routing method, kind of like smart routing, where it shoves around. Let's see, shoves around all the components. Problem is you end up with these very fragmented nets. So my plan eventually will be just to straighten these all out and get rid of all this horrible, like, I don't want little things like that. Mainly because I just want it to look nice. But also, it's going to make the file size massive if I've got all these tiny little fragments. Actually, the current thing I was trying to do was I wanted the these digital signals to make sure they weren't too close to this, which is a voltage reference. And there's all sorts of analog signals that are mixed on the same layer, which is probably not ideal. It'd probably be quite nice to pair some of these signals together close to each other. But what I need to do first is, you see these lines? These are the rat's nest lines, which tell us we need to get some wires over to here. I was putting this off because it's really awkward. There's two things. There's 1V1, which actually I wanted to have a look at the reference design. If I just do something, if we look at the RP20, because the chip manufacturer Raspberry Pi provide an example. Let me just load it up. Is it loading? Aha. So I have mistakenly left out this ground pole. Locked. Oops. Why is that not pasting? Let's try that again. Hmm. It needs to be there. Oh no, but that's actually, wait a minute. View. I was thinking, oh no, I've routed all around them, but it's fine because it's on a different layer. Oh no, I can't do that. Can't do it on that layer because that'll cut this 3V up, so I have to do it on something else. I'll do it on the inner one here. Either way, I need to do via. Oops, that's a massive fire. I'll do a via. There we go. For each one. Oh no. It's just going to have to go around it, isn't it? Where's the other 1.1V? No, it's 3V. There it is. Maybe this one might have to be here. Put a via here. Oh, there's a via there. Now, am I going to do this on the bottom copper? Or should I do it on the internal copper? Do it on the internal. Right, it's making a complete mess of the wires underneath. Fortunately, I can't have unfortunately I can't have can't remember what I was going to say. So now I've done this complete mess. I need to see if I can sort of squeeze everything through these gaps. If I put this like that far. My computer's thinking. It seems to be very CPU intensive. No, I can't do it. I don't want this fire to be too close. Guessing, could the fire just go over here? I'm sure that's fine. And that will give enough space for all this. Just try and straighten all this stuff out. Can I drag this over? Apparently not. Yeah, that one can go over. There we go. See, I don't just end up with these incredibly fragmented nets. And it's quite hard to recover from it. See, really what I want to do is just shovel these into each other and just have them straight. If I just I might just have to end up see, like that worked. Stop. Yeah. That I can't recover. Ugh. Okay. Bit cleaner. See, I don't want this to do this. I just want to see if I can drag this back. Oh, stop. There we go. Will that fit? No, it won't fit through there. Just cleans it up a little bit. If I can, I'm going to drag this over here. No, I'll just delete this, I think. Drag these over. And then continue this over and just put a via here. I just want to neaten this up. It's good to try and keep this middle bit clear because it is a heatsink, so it's good to have as much copper as you can. Okay, that solves that problem. There's a few other problems, like, what is this? Oh, that's just a boot resistor. It needs to go to that pin. But I don't want to block this 3.3 volt, which has been blocked already. So I need to put it somewhere. It really should just be with the here. And there's this. This is a capacitor that's missing a home. Is there 3.3 volts without a capacitor? It's that one. I feel like that one was missing on purpose. There's 3 volts there. 1.1. 3.3 here. But it doesn't connect to it. 3.3 there, though it doesn't also connect to it. 3 point there. 3 point there. With oh no, it's there. If I look at the reference design, that one. It's probably the capacitor for that one. Just look again. the I want to look at something that I've gone. The crystal looks strange. Ah. Right. It's probably all right here. These are the pull-ups. They should really go the other way round. How many wires are there? Oh, have I... Strange. I ended up with 50 wires in one place. I want this to be as close as possible to the pin it's for, but also why do I have two sets of wires there? No, I keep disconnecting. Look, if you see, I'm disconnecting this. I find an ideal position where there's a fairly decent path around here. We put the wires. These are pull-ups, they can go literally anywhere on the line. Because I2C has pull-ups. Because it communicates with the open drain, open collector. And then this just needs connected to ground. Okay, there's that solved. This has now become disconnected. Where's this meant to go? Oh, this is the one I don't know where to put it. I'll leave that for now. Now, the only task is I've got to do this. Oh, I disconnected that to let some lines through. Why not just... Just need to go there, but without interrupting the USB line. So that I can do this. It looks like I can break these out to here. Problem is it lands right on this. And not only do they not go in this direction, they want to go that way. Really, they need to land here somewhere. What are they? They're just gates. They're IOs. Looking around, it would be ideal if it was here. You could swap with these, but what are these? These, no, that's a fixed peripheral. But it'd be ideal if it could swap with something on the right. It can't swap with that. Up here would be pointless anyway. Down here would be difficult anyway. And that's just fixed peripheral. So it is just going to have to be here. I need to push these down. I mean, to avoid this, I probably should use another ribbon cable, but I think it would just be better if I didn't do that. I'll use some nice thin tracks. Use the smallest wire we can. No. Let's get pushed a little bit up. See, I'm pushing this away. Ah! Stop it. I might have to turn off. Just turn it to highlight. I swear my wires have too much clearance around them. But maybe they do need more clearance. Maybe I should do. There's just no room for all these wires. And even then, what am I going to do with them? maybe I'll have to go do some weird thing around the board like that. I'm not sure if that's a great idea. Hey Luke. Yeah, I'm struggling. I've got it set to the smallest possible clearance. But it is small. Look all that. I just got to get these 4 out, basically. And then I have no idea, I just have to think what to do with them. I might have to break my rules, my layer rules. Put it on this layer. Thing is, if I go across, I don't want to cut across this because that's the root of ground that way. But then I've got 2 ground layers, so I don't know. Maybe I should do it on the green layer. I've got these wires set to the smallest possible one before they charge you more. I can't really pull that down anymore because that's the decoupling cap. Guess I'm going to have to push these up more. They're quite chunky. I don't think they need to be that thick. I just made them thick just out of because they're analog. I'll just see if I can shove them this way. Guess if these come out further this way. Now maybe I can put this up here. Oh, there's loads more space. This is it, you start getting really desperate. Luckily this is the last major thing I've got to root. I've got to get them down there. It's going to be a bit of a nightmare because look. Just got to get them to this area here, I think. Now, I could walk them all the way around here, but I don't think that would be a fantastic idea. I'm probably going to have to cross them directly across, which isn't a fantastic idea either, put them directly across signals. But they are digital signals, so that's not a huge problem. Thankfully they're not analog signals. They're gates. Maybe I'll just do that and see if I can get away with it. I might have to do it on the bottom layer. Do it as small as I can. And they've got to get to here, I think. Don't do that. I'll zoom it in, wait. Just trying to get these 4. Four gate outputs. They should be going, ending up there. Which means they are under the memory chip, but there's a top layer first, and there's a whole ground plane in between, then the signal layer, and then they're on this. That should be, it's not ideal, but that shouldn't be awful. Then I might just drag them. Oh, look at that wire. I just want to drag them so they're close to each other. Actually, really, this one should go behind. This one should go slightly in front. Then try and get these straight. And put that one slightly behind. Might put it back into highlight mode. There we go. Now the problem is I've completely blocked off this because it wants to go back on this path, but it's a component on the top and it'll have this inner ground layer, sort of. It's a bit of a mess, this. Back to shove. Oh, I could do that, look. I'll do that. There you go, let's rejoin that. Now I want to bring them down here. This can go right over here. And I think I want this one to go this way. And if I'm bringing all these cables down, I don't want to block these wires, so put the wires this way. This one that way. Look at this mad. Not sure if that's needed. Let's have a look again. We want these grounds to go over here. It's good to do that anyway because the ground is in that direction. I think that's enough space. Sort of an island here. I don't think that's a problem. Now my smallest routing, just want to bring these down. I want to keep them hugging this side. Got to go all the way down. Oh dear. Might turn off shove. There we go. Cleared that out. God, it's going to go a long way, isn't it? This one goes down here. This one. There. It almost would be better if you had chips just had I/O expanders separately. Had its GPIO, had separate GPIO. Because then all you would need to push around was a bus. And then you wouldn't need all these insanely long paths, which aren't healthy. I think I'm going to do an incredibly boring video later on where I just really straighten these tracks out, because it just takes forever and things just get upset, disturbed. There you go, that was the last sort of load of pins that needed. You can see they all go up here. Weird little thing there. They all go up there. They do a little bit of a dodgy path on the bottom layer, just because I ran out of space on this layer. I mean, what could I have done? Could I have just gone down here and across that way? Maybe. We've got so many incredibly fine wires in this. I wonder if it's a bit of a risk. You know, could it be harder to manufacture? Right, so we've got some other things that... Yeah, look at this. What's this? Oh, I've accidentally shoved some important ground pins. Oops. No. Some important ground. Probably don't have to be that chunky though. Oh no, that is the maximum. Basically, these shouldn't be here. This is the... Well, it isn't. Well, this is the buck converter. I don't want to mess with it. So I don't think any of these should be anywhere near. Okay. What other weird stuff is going on? That got disconnected. Be reconnected like that. What else is not connected? Oh yeah, on the bottom, these pull-ups need to get to 3 volts. Where they go is unimportant. this is something with a missing ground. This, oh, I hadn't sorted this out. Oh, what? Oh, that's kind of convenient. This can just go to there. Oh, something missing ground. No, probably don't want to attach that there. Much better if I did this. Is it though? Because now I've messed this. Basically need to bring back the regulator. Huh. These capacitors too small. For now I'll do that, but that's not ideal. Yeah, I need to clear these out from underneath the switching supply. Ugh. Didn't really want these to be like this. Oh. I might just put it on highlight. See, this is how you make it cleaner. Just less convenient. Nope, that still hasn't cleared it out of the way enough. That's because these are in the way. I need to be completely off this. And I can't go there because that's USB. These wires are in the way. What's to the left of it? That is something that can move. And I can move these wires out a little bit. There's nowhere near enough space. I need huge amount of space. Right. Promise after this is done, we'll get something a bit more exciting. Get rid of that track. I'm basically trying to... There it is. What? I need to detach it fully from tracks because they just get in the way. I just want it to go up here. Not ground. Oh. Now it's decided it's a different kind of net. Thank you. A bit shoved back on. Nope, shove's not helping. So you can't see me doing that, but I'm opening up a menu. Right. I've gained that. But now this crazy thing. I'm now just doing it manually rather than using the auto shoving tool. Wish there was like a defragment trace tool or something. Because it's handy to be able to shove things around, but at the same time, it's horrible how all the traces become fractured. You know, they become lots of little tiny traces. Or what? Still too close for my liking. Fractional. Gaining a fractional amount there. Hopefully that's far enough away. It just needs some fires. basically, I think. I wonder if there's a way to look at the different layers. I know you can do it by hiding the board body. No wait, that doesn't need to be so big. To put a shelf back on. You can't see it every time I change this because it's in the mode. I'm going into the menu and changing it to shelf. Can't seem to manage it either. Oh, it's so close. Look at that. Oh, there we go. That'll do for now. Oh, what's with these This is looking pretty good now. How long have I got left? Ideally now, if I was doing this board on its own, I would do a DRC check. But there's so many other things that aren't routed yet. The cool thing about this bit of the board, it could probably be reused in other designs. Especially if I designed something, wrote a program and I quite liked it and wanted to make it a module, I could do that. Now the next thing is, this is something I haven't really solved. Oof. I've gone ahead and not implemented it. A lot of routing coming through this middle here. Where I wanted to put the SD card was in the middle, but maybe, like, why does an SD card just go in the middle? It's probably good if it was. Oops. Oh, you can't see this, sorry. I'm trying to move the SD card was here, but I'm not sure if that's a great place. I wonder if it could be... I'd like it to be so you could press the buttons on the right of the screen. The thing was, I was trying to put the SD card through because the idea was it was going to go through 3 layers, so it was going to come from here, I mean, it might be good if it was on the left hand side. What if it was somewhere like this? That would mean, that would mean that the, say, connector for whatever should be on this side. It told you right where the power supply is though. I think this inductor is too big. I think it should go here. Which is convenient for the connection, and it's also convenient for routing. And the idea is this board is 1.6mm, so have a connector like that. And then there'll be 5mm between this board, and then there'll be another 1.6mm through this panel, and then there's 10. Oh yeah, because the jack is got an LCSE number. Zero in stock. Right. Zero in stock. There was loads in stock. Might need to pre-order some of these, make sure I can get them. Let's assume I can get them. The other jack's at 8. So I was leaving 9. Well, I just rounded it up to 10 with a. Oh yeah, with a 2mm panel. So that seems right. There's something wrong with the schematic. I have connected it. This one's fine, but this one is connected to ground. But it isn't. Oh, it's this here. I call it SD ground. There you go. And then this line shows. So this can't be. This SD card has to be above that line because that's where the PCB, it goes through a PCB. That's where the other part of the PCB is. Got it on too fine a grid. And I'm using this connector. Is this a header? That sticks out sideways. It's not a surface mount header. Did I work out? No, there's no part number for that. So I need a surface mount, 1.27 pitch. Wait, what's going on? No, I don't want to be in that. I want to be in LCSC. So I need a surf. Thing is you need to be careful not to over specify it because the database might not be. The database isn't always right. most popular. I want a socket. Don't want pin headers, I want pin, what they call them, female headers. Really, I need surface mount. Like that. And, oh, that's another point. And it's 2 times 4. There you go. Say we choose that for this one, that one, sorry, for this one here, which is where it plugs into on the board. Oh, I already had chosen one, sweet. Oh, I hadn't. Not on that one. The only problem is if you look, it has a height. So it's going to be 4.6 above. So it's going to be there, and then there's going to be a... Whoa, look at that 4.6 millimeter socket above. So this wouldn't fit in. Because it's a header and it would have to come here, up to here. And then it's hitting the PCB above. So I need to come up with a different solution. The socket would have to be... What if I had... Did they do a right angle one? Probably not in surface mount. And that starts to become quite a niche product. Yeah, like this. Bit bizarre. What if it was side 2 times 4, 1.27. What if it was a through hole one? Then it's it's 3mm above. What width is it? Oh, it's 1.27 times number of positions. No. Sure, it's +1. .08. So if it was that, then because this one is so if it's this one, so this is a through hole right angle socket, and if you see this blue square, that's where it will stick out sideways. Then this won't, I need a pin header that is probably through hole because I don't want it to, the pins to come out sideways. It needs to be 1.27 and 2 times 4. Not surface mount, through hole. Got very long pins. More into that one. There's a short end and a long end. So if it's that one instead, then that is dim B 5.08 by 3.4. Then, and then so basically this, it means this one is now a change the footprint. This one is now a pin header 1.07 horizontal. It's not a header though, it's a socket. And that's the problem. I could probably pull them. I might get the actual real footprints from JLC. and 3D symbols. I've got it open already, wait. Oh no, that's not Ubuntu. I think that was Ubuntu. And that's the header. Created a 3D model. You won't see this because it's my files, but just a moment. What I'm doing is I'm going to my Ubuntu directory and getting the footprint and copying it to my the library that I have for the this project specific library, and I can see it has a footprint and it should have a 3D file, which will be really useful for this. And then I'm going to copy that one, and it looks practically, you can't see this, but it looks practically the same as a file name. So if you look, when I do this, so this one's going to be 890, you change the footprint, footprints are just loading. And a bit of an annoying interface. We need the library for this project called Green Screen. You see there's two. This one is horizontal. That one. And this one is the vertical one, this one. Now if I update, yeah, so I should have, the idea is that should fit really neatly here, hopefully. And then this is my debris. I pretend there was, I changed this inductor. It's a bit in the way at the moment, but I can, hopefully there's a 3D model. You can see all my files. Oops. What are we doing? The sideways one? Yeah. Now annoyingly I always have to shift these around. Top. Orthographic rejection because it's a bit easier. There you go, that should be it. It's not. These look about aligned. What about this body? It's not. Yeah, the body is in the board. Yeah, so it's something like that. Then on this one, should be this. So this one is a pin header. That seems fine, although it looks like it's upside down. So if we look, the idea is that in this board there'll be a hole. That there'll be a header. And I do know they flex up, it'll be pretty awkward. Hopefully that will work. I could try and see if I can get it into a different program and simulate. Once I've laid it out, I'll try and separate these boards out and try and simulate them going together. It's going to be quite complicated to do this, but it's great because it means our SD card signals go straight into this connector and straight up to a SD card socket, which is good because we do want to do high speed SD and we don't want to destroy the integrity of the high speed signals. Although I don't think 2-point pin headers are the most ideal thing. Maybe if this doesn't work, I should just have another ribbon cable. Yeah, because this is going to have to slot through here somewhere. And I'm not going to be able to do that because this has got two components on it. The slot will have to be big enough that this SD card reader can fit through it. Have I got the footprint for that? I don't know if... no, that's not it. I'll have to find that. I don't even know what this part is. Oh, I seem to have two LCSE numbers for it. It's that one. Have I created myself loads of problems? The idea is I'm going to shrink down this inductor and then I'll have to just work out if it should go left or right. Probably needs to be all the way over here. I might need to clear all this stuff and push it over that way and then have a connector here. Because what I'm thinking of is that. Something like that. Oh no, I've got it on the left. Because this is the back, so if I wanted it there, it would have to be over here. Huh. But then that's a very simple connector. That can be moved easily. It would probably end up being somewhere down here. It's where stuff stops becoming aesthetically decided and it's starting to become practically decided. So it's going to have to be over here. Oh, that's a shame. I wanted it near there though. Could I change around my buttons? Keep trying to use keycad keys in maybe the screen will just have to go to a weird center. I quite liked having it like asymmetrically to one side, but maybe it's just going to have a weird center thing like that. It's not terrible. Delete that. I think I'm going to call it a day now, but I think it's going to it's going to have to be a massive slot in this board to let this connector through. It's probably going to have a funny like a slot with a bigger chunky bit. So these header pins can fit through that board, so it can go to the one underneath. Or you mount that onto there, you get it in, and then you'll put this board over the top of it. So this board is going to have a slot that's as wide as this board coming in, with the micro SD card, so it's going to have to be quite wide as well. But then when you put the front panel on, it'll key here. So hopefully it'll just be pressure, because these are threaded mounts. So it'll just be flapping in the wind, but hopefully this slot here is going to be a bit ugly, because you're going to see the edge. You're going to see the edge of the PCB sticking through, and it's going to be square as well. So it's going to have a round hole with a square thing in it, but that's kind of needed because the SD card needs to be guided in. It's going to look a bit ugly, that. Yeah. Anyway, I'll be on tomorrow again at 7:30, where I will be exclusively probably working on this SD card bit, and then on what day is it today? It's Wednesday. So then on Thursday, I'll sort out the SD card thing, and then on Friday hopefully I'll be onto the connectors. I really need to order this. I'd like to show it at Super Booth in on May the 7th, and that is in 3 weeks. So ideally I need to be ordering this board Monday, and then if it doesn't work, I'm screwed. I'll just have to show it physically as an idea. Yeah. Hopefully though, I worked hard enough on it that it will work. And I've used the design guide. I mean, this is kind of crazy. The this routing out from underneath the chip. But I think I've kept pretty cleanly to the switching supply, which is the most important thing, and the crystal, that the crystal's got a nice space. Maybe that's a bit dodgy. Yeah. Anyway, thanks for watching. See you tomorrow night. Bye.